Hi, and welcome back to Psychology with me, Mr. Snyder, and today we are going to discuss the second half of this domain about thinking and intelligence. Today we're going to focus on thinking. Learning targets for today are to talk about the cognitive processes involved in understanding information, talk about problem solving, decision making. We're not going to do 25.3 about non-human problem solving abilities. We've kind of already went over that. And we'll talk about obstacles to problem solving. So thinking and memory. Thinking cognition means to know. It's the mental activity that's going on in the brain when a person processes information, including organizing that information, understanding it, and communicating it to others. Things that we do while we think is memorizing, make decisions, compare different information, and problem solve. And this comprises both of images and concepts. Mental images are representations that stand in for objects and events that have a picture-like quality. If you think of a horse, or if I say the word horse, do you think of the word horse, or do you think of a picture of a horse? Most of you would think of a picture of a horse, maybe with some other things in a field where you would normally see a horse, or in a stable. There's other things associated with the horse. It does take longer to view a mental image that is larger or that covers more distance than a smaller one. And I'll get to an experiment here in a second that proves that. Mental rotation, if you think of its cube in your mind, you can rotate it just like you're rotating it in your hands. They're rotated like we do physical objects in our hands. And how do we create a mental image? Well, it's almost the exact opposite of an actual image. The information goes to your eyes, through all that junk, then the visual cortex and processing, and then it goes to the areas of the cortex that compares new information to an existing information. And we either assimilate or accommodate that information. The information, if we form a mental image, goes from the areas of the cortex receive that stored information to the visual cortex, and then the image is perceived in the mind's eye. And PET scans of the brain show the activation of the visual cortex while we're forming a mental image of something. Here is Kosslyn's Fictional island, and they're asking people, there's various places and things on the island, and they're having people imagine moving from one point to the other, and if they ask them to move farther away, it will mentally take them longer to move to the locations far away. So now concepts and prototypes are also ways in which we organize information. Concepts are ideas that represent a class or category without being specific. It allows us to think about objects without having to think about all the specific examples, like books, sports, music, fruit, birds are all concepts. It allows easier communication with one another. It also allows identification of new objects that may fit into the concept. For example, if you come across something that looks like a dog, more than likely you're going to think of it as the concept of a dog. And this is an important tool in problem solving. A prototype is the best example of the characteristics of the actual concept because it matches what you think. This is affected by culture, experience, and surroundings. So if I told you think of a car, you'd probably think of your favorite car, or the thing that most exemplifies what car means to you. Could be your car, could be a very nice concept car. It depends on your culture, experience, surroundings with cars. For example, in the U.S., we would say, if asked to pick the prototype of a fruit, apple, banana, or orange. But some people in other countries would pick guava or papaya. There's greater differences in prototypes between dissimilar cultures. For example, America and Taiwan would probably have different prototypes of fruit. People, what they do is they compare an example of a potential concept and the prototype of their concept to detect a match. Although olives and tomatoes are fruits, they do not come to mind as fruit because they aren't sweet. And so they don't fit into our existing concept of fruit. Schemas, we've already kind of talked about, are mental generalizations and hierarchies about objects, places, events. For example, you expect if you go to the library you picture books, tables, computers, a place to check out, maybe some windows, bookshelves. Those are schemas of a library. Scripts are a sequence. It's kind of like a schema, but it's a sequence of activities. So going to a movie, you have to get there, buy tickets, buy concessions, find a seat, etc. So that is the script of going to a movie. Now let's talk about problem solving. It occurs when a goal must be reached by thinking and behaving in certain ways, and it's one aspect of decision making. You have to identify alternatives, evaluate alternatives, and then choose among them. We're going to go over these common types like trial and error, algorithms, heuristics, insight, and creativity. Trial and error are basically mechanical solutions. You try one method. If it doesn't work, you try another until the successful one is found. This is a rote, learned set of rules. Algorithms are specific step-by-step procedures and processes which will always get you an answer. It will always get you the correct solution, assuming there is a correct solution. However, it's not always practical to use. It is useful in computer programs. You've probably studied it in mathematical formulas. Heuristics are a step down from algorithms because they're just a rule of thumb. It's a simple rule you can apply to many different situations, and it'll probably get you the solution to the problem, but maybe not always the correct one. We're going to talk about types of heuristics. The representativeness heuristic assumes that an object or person sharing characteristics with the members of a particular category is also a member of that category. So if you saw a blonde, good-looking guy, usually has his shirt off, ripped, near the beach, you would assume he is a surfer because he fits into your concept of what a surfer is. But we don't know that. That's just he represents what we think a surfer is, and so we label him as a surfer. We don't know if he's a surfer or not. The availability heuristic is based on the estimation of the frequency of an event, and you base that on how easy it is to recall relevant information. So are there really more school shootings going on in this decade, or are there just more media coverage of it? Shark attacks is another good example. You hear about shark attacks all the time, but the odds of getting attacked by a shark are very, very, very small. And so you use the information available to you to make decisions, but sometimes that information is not always the best to use. Working backward, this is reverse engineering something. You may start with the goal and break the goal down into sub-goals. Or if you want to run a marathon, you look at where the marathon is or the date of it, what date it is now, and then increasingly work your way up until you can run a marathon. Making diagrams helps you organize the information connecting the problem, and then testing those possible solutions and eliminating them one by one. Insight, we've already talked about. It's the sudden perception of a solution to a problem, that aha moment you get. And then during creativity, sometimes we can solve problems by combining ideas or behavior. There's two different ways to do this. There's convergent thinking and divergent thinking. Convergent thinking is taking all the available information and coming together for one probable solution, one answer to the problem. It uses the previous knowledge and logic of the subject, and it works well for any routine problem solving that you may have. Divergent thinking is the reverse. You take the situation and you think of every possible solution that you could. You brainstorm, and so you come up with different ideas or possibilities. And this type of thinking is attributed to creativity and intelligence. And it's not prevalent in all cultures, but some it is where creativity is prioritized. Characteristics, most productive periods of divergent thinking occur when you're engaged in automatic tasks. You make links and connections at a level of consciousness just below your alert awareness. And you're less prone to something called functional fixedness. And functional fixedness is fixed on the function. It means that you only see something, an object, as being useful for what it was designed for. An example is the string problem, which we'll get to here in a second. And then functional fixedness is a type of mental set. You use problem-solving patterns that have worked in the past. And that's just a way that your brain saves energy, and it's lazy. Laziness is built into our code, pretty much. We want to save energy because we didn't know when our next meal was coming back during days where we had not evolved yet. But solutions that work in the past tend to be the ones that we try first. Lastly, another barrier is called confirmation bias, and it's where you search for evidence that only fits your beliefs, and you ignore any evidence that does not fit those beliefs. And this is a prevalent characteristic in multitaskers. Here's an example of the string problem. There's two strings in a room, and the goal is to tie them together, but you cannot reach them no matter how far out you reach your arms. The only other object in the room is a pair of scissors, which we see as being able to, this says pliers. I always say scissors. The pliers are just useful for squeezing things together. The scissors are just useful for cutting things, unless you use it as a weight at the bottom of a pendulum and then swing the string to yourself and you're able to tie them together. So that's an example of functional fixedness. The dot problem, to draw 4 straight lines through all 9 dots, you don't realize that you can actually draw outside the box and make longer lines than just the 3 dots that you see in the middle. So that's a quick lesson on thinking. Make sure you fill out your learning targets, and I will see you back here in class. Bye-bye.